If you're a STEM student or anybody that writes down math formulas, then I've got a great project for you, particularly a project while we're all stuck at home. And the idea is this: how do mathematicians write beautiful mathematics? I don't mean the content of the mathematics. How do they actually display it? For example, this is a portion of my PhD thesis, and as you see, it's a combination of formulas and math diagrams as well as just normal paragraphs. So how do you do that? Well, in this video, I'm going to give you an introduction to LateX. LateX is a markup language, and what that means is that if you write your math formulas with a little bit of code, it's not so bad, I'll show you how to do it, then the system is going to display the code for your math formulas in a very nice way. Now, there's many ways to write in LateX. What we're going to use in this video is Overleaf, but down in the description, I'll put in installers for PC versions and for Mac versions of LateX as well. But Overleaf is a free cloud-based one. All right, so let's begin. I'm going to go to overleaf.com, and I already have an account, but you can come up here and either register for an account. I'm going to simply log in. Now we get this list of projects we previously worked on, but I'm going to go to the top left, click New Project. And there's many different templates down here, but I'm going to click on Blank Project, and I'm going to come here and call it Hello YouTube. That will be the name of my project, and I'll click Create. And so this is what it looks like. On the left side, I have this code here. This is the code you were typing in LateX. And then on the right-hand side, we get what it produces. So we have to understand how this code works, and it's not so bad. So let's take a look. The first thing I'm going to observe is that there's something called begin document and end document. And in between begin document and end document is where you do all of your typing. So for example, if I came down here and typed hello world, then what is going to happen is that that hello world is going to appear on the right-hand side. Now, to make that appear, up on the top here, you see a button called recompile, which basically just goes and runs the code and gives the document. And you can click the arrow and turn auto-compile on to on, which means that every few seconds it will come and do this, and that hello world that we typed over here now appears on the right-hand side. The other things I have between begin document and end document right now is something called make title. Make title just goes and outputs this initial code that I have on the top. And then something called section introduction, and it basically gives a nice bolded when you put it \section introduction. It creates this number 1 out the front here and this large introduction. So that's what's happening between the begin document and end document. The initial portion here is called a preamble. And in this preamble, some of it is self-explanatory, some is not. The first few things are part of the process of making the title down below. I say what is the title, I say what my name is, I say what the date is, and you can change those appropriately. And then when you click make title, what it's doing is just telling LateX to display these things that you typed up in the preamble. At the very top, the very first line called document class article, you probably use this every time, but there's different document classes for books and for presentations, and you can explore those in the future. Then the second line is also something that just Overleaf is just doing as a default. When you use a package, it adds new functionality, new libraries of commands and ways to interpret symbols. And this is just a default one that we're using. In fact, we're going to see how to add different packages later on. Nevertheless, we just use these defaults, and it's time to go down here and make some changes into our section. So let's begin with a formula. And what should we do? How about Euler's formula? To make a formula, you use 2 different $signs, and you wrap the thing that is a formula in between the $signs. And so let's do, how about e to the power? And so I write my little caret symbol. And because I want to do e to the I pi, I want 2 things to be up in the exponent. What I do is I put curly brackets, and curly brackets are a way of just lumping together code in LateX. So everything that is inside of these curly brackets will be put up in the exponent. And what do I want to put? I'm going to put an I want a pi symbol. And the way to make a pi symbol is do \pi. And as you'll notice, as it slowly goes and does its recompiling, now I get e to the I pi appearing, and perhaps I want to add +1 and equal to 0 so that we can get our famous formula, Euler's formula. This \, business, you could do \alpha to make an alpha symbol, \beta to make a beta, whatever you like. Generally, \ is telling LaTeX that you're about to give some command, in this case, the command to make a pi symbol. This type of formula is called an inline formula and basically means that the formula is aligned here with the text. But we can also do formulas that have not a single $ wrapping it, but a double $ wrapping it. And what happens here is it creates its own new equation environment. So for example, I'm going to do a fraction. The way to do a fraction is \, which tells me I'm going to do a code. And then I'm going to type frac for fraction. And what you'll notice down at the bottom where it pops up, it sort of tells you how to format it, is that it takes two inputs in curly braces. The top one is your numerator. I'll put a 1 there. And the bottom one, let's do an n, say, is your denominator. Now, what's happening here is after it recompiles, it's going to appear as this nice fraction on the right-hand side. Often formulas that are long, complicated, and messy and might take more than the amount of space that you'd want them to be nicely aligned in line should have these double $ to create this sort of own math environment. Okay, I'm going to add some more things to this. I'm going to put a 1 plus. I'm going to put a bracket around the left-hand side, a bracket to the right-hand side, and raise it to the power of n. Some of you may know where I'm going with this. But what I want to notice is, on the right-hand side, I don't think it looks very good. The brackets are sort of too small. I want to raise the entire thing to the power of n, but the brackets don't look that great. So what I'm going to do here is a command to make auto-scaling brackets. Where I have the first bracket, I'm going to write \left to tell the system that this is a left bracket. And then I'm going to do a \right to tell the command that the final closing bracket is also similarly an auto-scaled one. And what you get now is these brackets that scale to be exactly the size they need to be, 1 plus 1 over n, all to the power of n. So this is how you can make much prettier different formulas. Okay, what else should I do here? Let's put a limit out the front of this thing. The command for limit is \limit. And now for my limit, I want to put something underneath of it. And so I'm going to do underscore, and I'll put in some braces here. And this tells me that whatever I put in between these braces, currently nothing, is going to be underneath the limit symbol. Much like how the caret told you to do the things that was the exponent of the exponential. In this case, I'm going to do n, I'm going to do \2, which is a symbol for an arrow, \2 is an arrow, and then to infinity is \empty. So as you see, there's a bunch of these different sort of symbols you have to start memorizing effectively, but you can look into them up pretty quickly. And what we have here is finally a definition for E. E is this particular limit, or this is one way to write it. If we want to have a bit more fun with this, we can do another one. So let's do an n to infinity in the same kind of way. We're going to do a new fraction. It's going to have an n on the top. This is coming from Stirling's formula. And then on the bottom, well, I want to do the nth root of n factorial. So how do I do an nth root? Well, I'm going to do \sqrt for square root. And then square root's kind of funny. Square root accepts a parameter, and by that I'm going to use two different square brackets, and I'm going to put an n here. And so basically what this code does is it tells me I'm not making a square root symbol, I'm making an nth root symbol. So square root, if you put the brackets around the n, tells it to make an nth root symbol. And then nth root symbol of what? Well, n factorial. And you put that all in, and when it recompiles, it's going to come here, force it, and create an nth root of n factorial, another limit formula for E. All right. We can do another. Let's do a sum one this time. So E is going to be \sum. This is going to make a big sigma. I'm going to do the underscore here to put something beneath the sum, and I'm going to write it starts at n equal to 0. And then I'm going to put my caret and write an infinity, and this is all going to come out together and make a nice sum from n equal to 0 up to infinity. Looks like I have one too many braces for now. Okay, and then what I want to have it be a sum of, it's 1 divided by n factorial is how you work. Let's compile it to force it to happen, and we get this other formula for E. All right, let's do one more. We can also use continued fractions. You may not have seen this particular definition before. It's a kind of a fun one. So what I'm going to do starts with a 2. And then it's a fraction where there's a 1 on the top, and then there's something I have to put down on the bottom. But if I then go inside there, and what am I put on the bottom? I'm going to put a 1 plus another fraction. It's a fraction with a 1 on the top, and then something along the bottom. And then what is the thing on the bottom? Well, it's going to be a 2 plus a fraction with a 2 on the top, and something along the bottom. You see what's starting to happen here is it's going to come along as it compiles. And it keeps on having this sort of pattern of fraction after fraction. Let's do another one. It's a 3 plus a fraction with a 3 on the top and something on the bottom. What is that something on the bottom? It is a 4 plus a fraction with a 4 on the top and a something on the bottom. Let's see how that one compiles. Oh, I have a big error message. That means I formatted something improperly, and it looks like I had one too few braces. So let's run it this time. Up, there it is. And what do we want to put? Let's try to do a dot, dot, dot. If you do backslash D dots, that's going to give me some very nice diagonal dots. And so we have this sort of look down here. Oh, I don't actually like that. There it is. Now it's compiled 4 plus 5 plus, and then the dot, 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 just to indicate that it goes on in that way. So this is called a continued fraction. All right, so that's a bunch of the different types of commands that you can use. We're going to do more, but you might want to say this is starting to look messy. You might want to clean it up. And so one of the things I want to talk about is how you make lists. And so I'm going to do something called begin enumerate. Enumerate, I can't spell. Enumerate, there we go, and we're going to close it, and we're going to come down to the end of the document. It will fix all of my error message in a moment, and end enumerate. All right, let's recompile that. Now, I haven't done anything, except I've created all of this text between begin enumerate and end enumerate is within this enumerate thing. Well, what does that do? Basically, you can write backslash item to create items on a list. Let's come down here and do another item there. And one more item down here. And as you can see, you have this nice sort of 1, 2, and 3 appearing. And so it just organizes a little bit better, especially if you're doing, for example, multiple homework problems. If you don't like it being numbered, you can come and double click on the enumerate, which selects the enumerate on the top and on the bottom. And you can write itemize here and come along on the bottom and itemize there as well. We recompile this, and itemize gives dots opposed to numbers. All right, so that's a bit of an introduction here. Now I want to go and let's do a new section with some new commands. Remember how at the beginning I had this section which was called introduction? That was our first one. By the way, if you don't like that one appearing at the front, you can come here and put a star in front of it, and that's going to it's going to get rid of this one here. Star just sort of takes away the numbering. Nevertheless, let's come down here and do a new section. How about more formulas? Something like this. And here I want to talk about just a few formulas that you may well need. I will put a star there as well so we don't get a 1 in front of that one. I'm going to do a few more formulas you might need in calculus or linear algebra courses. If you have any other courses or any other symbols, it's totally fine for you to look up and figure out what that's going to be. For instance, one of the most important formulas is integrals. So the integral with a on the bottom and b on the top and then f of x dx is going to give us, well, an integral formula. I have my brackets in weird spots, so let me rewrite my f of x a little bit nicer, and it's going to look like this. Now, the next formula is actually something that we can't do with the package we have right now. Remember at the top we said that we could add these use packages to the preamble, but the next symbol is not in this one that we have established. I want to do a new package, and this is one I would always suggest using, AMS Math. This is the American Mathematical Society, and it's a whole bunch of new formulas, new symbols that do not exist in sort of the native tech environment. So now that I have added that package, I can do something which is a new symbol that didn't work previously. Backslash. I'm going to do an integral, but I'm going to put more than one I. There's a single integral, there's a double integral, and there's a triple integral. So 3 i's in your integral sign. And then maybe I want to come along and write f of x and y and z. Dx, dy, dz, and this is going to give me a nice triple integral. So as you go in Google and find new symbols, you may sometimes need to add new packages to allow you to use those symbols. You just do those up in the preamble. Okay, what about for linear algebra? One of the most important ones is being able to do vectors. So you do backslash vec and put your v there. I could define this, for example, as v sub 1, v sub 2, v sub 3, something like this. And this is going to give me a nice little vector with an arrow hat on it. You might want to take a dot product between two vectors. So I could take, how about a v vector? And then to make the dot, you do backslash c dot for a central dot, and then a vector w. And this gives me a nice dot product between these two different things. Let's let it recompile so it decides there, and there we go, we have that. Okay, very nice. Final new sort of formula that I want to talk about is for matrices. Obviously, we have to do this all the time in linear algebra. This is another command that requires that AMS math. It's called a B matrix. And so here's the approach. I'm going to begin with a double sign on the top, and I'm going to give myself a little bit of space here. So all of this region here is my formula. And I'm going to do a begin. It's called a B matrix. And then I'll go for a little while, and then I will end my B matrix. I didn't type it fast enough, and so when it tried to compile, it shot me a little bit of an error message, but okay, nevertheless. Right now it looks pretty terrible, just got these two different brackets. But here's how it works. To type a row in this B matrix, you put a number, and then you put an ampersand to denote that you're going along your row, and then maybe say 2, and then I'll put an and 3, and then when you're done with your row, you put backslash, backslash. And so what I get here when it compiles is this matrix in brackets that is just a row vector 1, 2, 3. If you want to add a new row, come out and do 4 and 5 and 6. And you don't actually have to do the backslash on the very last one, but let's put it in there anyways. And it makes this really nice matrix. All right, two final things that I want to talk about, which is images and commenting. Suppose I had done this and then I decided I don't actually want this triple integral. I'm going to come along here and put a % sign in front of it. I'll hit recompile, and notice what happens to the triple integral. It goes away. So if you're not sure whether you want to display something, but you've been working on it, you don't want to delete it, you can just go and hide it behind the % signs, and that gives a comment. The final thing I want to talk about is images. How do you add an image? Because maybe you've made some graph somewhere else, either in some other software, or you've written it out by hand, you want to include it in your homework. How do you do that? So the first thing we do to get an image is I go up to the top where I've got my packages, and I'm going to use a new package, and this one is called GraphX with an X at the end of it. Now, to add the images, I'm going to click my little arrow over here so I see this. Main.txt, by the way, is just the name of this tech document that I'm writing in. That's where I put my code. I'm going to come here and click the upload button. I'm going to select from my computer, and I have an image there called definition of length. And so if I come along and click that, now in the sort of this folder, I have this image, just something I just wrote up by hand. It's kind of a long name. I'm going to rename it. I'm just going to call it length by itself. And now I don't have it yet in my document anywhere, but I have added the package that allows me to make a command to include it. Okay, so down here, I'm going to do include graphics. And I love what this little portion of it, you see how it pops up down here? It sort of shows how it formats. It shows that there's a section in square brackets, a section in squiggly brackets. The section in square brackets is basically you telling it size. There's many ways to do this, but one way is to write scale as some fraction of the original size. So if you sort of know how big your original document is, you can scale it. Other options are to make the width equal to, say, half the text width. There's different versions like this, but nevertheless, I'll stick with that one. And then in the squiggly brackets, I put the name of the image. So remember how we had called it length? So it was length up there, and so I will call it length down here, and it's going to recompile, and I'll scroll down, and there I have it, and I have my document just organized very nicely. All right, so, well, that's all I've got for you right now. I hope you enjoyed. I definitely encourage you to check out the description where I've got more information and the links to install it or the links to go to Overleaf. And it's just a great project to work on over summer so that all of your different homework assignments can be presented really nicely. Or if you're doing anything else that use math formulas, LateX is just so powerful because if you know these elementary codes, you don't have to worry about making everything spaced and look nice. It just does all of that for you, which is why LateX is so powerful and is basically used throughout mathematics and many other STEM fields as well. So if you have any questions about this video, then please leave them down in the comments. Give it a like. We're all mathematicians. We like algorithms. We know YouTube like algorithms, so give the video a like for the YouTube algorithm. And we're going to do some more math, not typesetting of math, more actual math in the next video.